So we're going to start with 1, and then we're going to introduce 2 at the same time, right? So for each of the following, determine the intercepts. I would say this, of the boundary line. That's what I mean by that. Rewrite the inequality.
Excuse the interruption, Ms. Ram, please contact the office. Ms. Ram, contact the office, please.
And then we'll graph using regular shading. Okay? What is the boundary line of this one? 4x minus 5y minus 10 is equal to 0. This is the boundary line. I will not rewrite it every time like this, but just so you understand, okay, this is the inequality, and the boundary line that goes with this inequality, we need the boundary line to know where are we going to cut our graph. Which way is it going to cut, okay? So let's do the x-intercepts and the y-intercepts. I really encourage you to organize your work like this, because if you have 2 or 3 of these guys, you're doing work all over the place. Okay? So I'm using this boundary line to work and find the intercepts. Is this cleaned up, guys? Technically, it's not quite cleaned up. We're going to bring this negative 10 over. So it's 4x minus 5y is equal to positive 10. That's kind of how I want to, so right on this side here, clean up, okay? Some of you need to do that with your rooms this weekend. Right? Clean up. When you're finding the x-intercept, we know that y is equal to 0, right? So really, this is just 4x is equal to 10. Divide both sides by 4. X is equal to 2.5. Newman, please. Okay. I read your mind, okay? 2.50 is the x-intercept. Is this okay that I just skip to this point, guys? I kind of just substitute 0 in and that term is gone, right? I don't bother doing that in here because it's too time consuming. For y-intercept, the x is 0. So you end up just with this part right here. So it's negative 5y is equal to 10. We divide both sides by negative 5. So y is equal to negative 2. So the point, the y-intercept is 0, negative 2. Clean this up nicely. Now we're going to rewrite inequality. I will take this with me one more time here. Okay, so by rewriting I mean isolate y, right? Isolate y. So I'm going to bring this over to the other side, and I'm going to bring this over to the other side. So I end up with negative 5y is greater than negative 4x, because the 4x turns negative when it comes over. The negative 10 also comes over, turns positive. And now what? Divide by 5, right? What happens when I divide by a negative? Flip the side. Only if you do this step where you divide by a negative. Okay? Don't flip it unless you have to. So then this is y. We flip the sign, so negative and a negative, right? If these two divide, it's just positive 4 over 5x. positive 10 divided by negative 5 is negative 2. This matches, watch, right? My y-intercept matches with that. I should observe that. And look what I'm going to do a little legend here. What kind of line is this? Dashed or solid? Do you remember? It's dashed because it doesn't have an equal sign. So this tells me that it's dashed. Okay, comma. Where's the true region? Is it above the line or below the line? If it's y is less than, do you remember where it is? You can peek on the previous page. It is below the line, right? So we're going to shade below because we're using regular shading. We're going to shade where the true region is. So the true is below. This is the most important step, and therefore we're also going to shade below, okay? Because it's regular shading. So for today, we're only going to do regular shading. We're not going to do reverse anything, okay? So here we go. We're ready to graph. 2.5 is right there. 2.5, 0. 0, negative 2 is right there. Now we can graph our boundary line. It's dashed. Okay, so make sure it's dashed. I will write the inequality somewhere. 4x minus 5y minus 10 is greater than 0. Doesn't matter which version of the inequality you include. Please label the true region. I'll repeat, I don't care what shading you use as long as you shade the true region. As long as you identify and label the true region. So we know that the true region is here. Okay, so that means that I'm going to put my ruler against the boundary line here. And lightly, why am I saying lightly shade? Because if you make a mistake, it's really hard to, and you don't want to cover up any labels. Okay, so just make sure it's visible and you shade the whole area. Okay, that's what we call our solution region. Which means, what's this region called? False region. Okay. Okay, guys, I know some of you are like, Mr. Dirksen, I want the test point back. Can I just use the test point? This is just for you, okay? Test point. Which one should I pick? The origin? The OG? No? Not funny? Okay. What will I get if I plug this into the inequality? What will the result be? False. Okay? So if you take that original, I would take the original inequality. I would not do anything else if you want to do it this way. Plug in 0. 4 times 0 minus 5 times 0 minus 10 is greater than 0. Is that true? Is negative 10 greater than 0? That's false. Which confirms what we've known all along. Okay? We took this test point, we plugged it into our inequality. Okay? We plugged it in and we realized it is false, right? It is in the false region. So therefore, everything above the line is also false. So you use my method. I like to rewrite because you have to do it anyways. You will see why in the future. So there we go. What's the time? 11:15. Can I just show you the part below how to do that mathematically? It's, if I ever ask you, is 40-30 part of the solution? Where is 40, 30? Let's estimate where that could be. 40 would be like way down here, and 30 would be way up here, right? It is possible that it's going to be in the false region, but we don't know for sure. So all you do is sub into inequality. That's all you do, just like we did here. So it's 4 times 40 minus 5 times 30 minus 10 is supposed to be greater than 0. 4 times 40 is 160. 5 times 30 is 150 minus 10. It's greater than 0. 160 minus 150 is 10. Minus 10 is 0. Is that, looks like possibly an emoji. Probably get an emoji out of that one if you type that in. Is that true? Is 0 greater than 0? That's false. So not a solution. Okay? Not a solution. Question, is this statement, would that be, it's another emoji right there. Is that okay? Is 0 greater than or equal to 0? Yes, this statement would be true had that, this is just a note. Okay, is true. Because you're asking, is 0 greater than or is it equal to this number? And because it meets the or part, the equal part, it is actually a true statement. Okay, I'm going to stop there. I'm going to ask you to try a few questions, okay? Go to page 23, and I will tell you which ones not to do, or if you want the challenge, I'm not going to stop you. 23, let's go to 23 here real quick. So page 23. Page 23 is all good. And 24 actually. If you come across a special question where you have a vertical line, you should technically also know what to do. But watch this, I'm going to just reiterate. Find the intercepts. Rewrite, then graph. And by that I mean shade, okay? So find the intercepts of the boundary line, rewrite your inequality, tell me if it's going to be a solid, right? Where is the true region and where are you going to shade, and then go ahead and graph accordingly, okay? So give that a try. See how that goes. Go off of my notes, and we'll come back perhaps to do another one.